the whole thing. And also we'll do some exercises. After this, we'll do some practices. Work done. Now I won't take you a lot of time, maybe 1 hour, because I know after you finish your school, it will be tiring the whole day and you still have to listen to the tuition. Okay, I'll cover it as quickly, as concise as possible. So work done first is that, okay, very simple, force and distance. Now in your slide, right, you have this FD and then cos theta, that one that makes it very complicated. You just think about this force and distance, okay? Because the cos data is actually for the sine only, right? What do I mean by that? Let's say you have a object, and let's say I pull the object, I apply a force to the right, and then the object moves at a distance same direction as the force. If the movement is the same direction as the force, then the work done is a positive. Okay, if the movement is opposite direction to the force, then the work done is going to be a negative. Okay, let me label the forces here. You have this force, this is the pull, the one that I apply, and then you have another force that is maybe the friction down here, F, friction. Two forces. Other than that, of course, we also have the mg and we have the reaction, right? But because the R and the mg, they are perpendicular to the movement, so they are irrelevant. Okay, they do no work because it's perpendicular. Okay, now only this two is doing work, the two forces, the pull and the friction. Now, how do you know positive and negative? If you look at the force, the pulling force, this is doing positive work because this force is same direction as the distance. So how do we say this one? We say that the pulling force is doing positive work. The pull force. Who is doing the positive work? The pull force. Or you can say, I'm doing positive work because I'm pulling it. Okay? Now, what about the friction? The friction is going to the left side and it's opposite to the movement. So I would say that the friction is doing negative work. Okay, negative work. Who is doing negative work? Friction. You can say the friction, you can say the floor, okay, anything. Now, another example. Let's say I toss a ball up. There's two forces acting on the ball. This is the force that I apply. I tossed it. And then when it is moving up, there's a force mg downward. Where is the movement of the ball? The ball is moving up. Okay, you need to see the distance traveled. This is along the direction going upward. So who is doing negative? Who is doing positive? The toss force is doing a positive work. So I'm doing positive work. I tossed it. The mg is doing negative work. Okay, so because it's opposite. So how do we say this one? The mg, the weight is doing negative work, or we can say the gravity is doing negative work. Okay, the gravity is doing negative work. So if you know this, if you understand this, then you don't need to put the cos data in. You just remember this F times D. Whether it's positive or negative, you look at whether the direction is same or opposite. Okay, so that is the first one. Other than that one, please remember your force and the distance must be in the same line. This is the first criteria. Okay, first criteria is that you have positive versus negative. What does it mean by positive work? If I'm doing positive work, what does that mean? You can think of it like this. If I'm doing positive work, then I'm giving energy to the system. I'm giving energy to what? To the object. If I do negative work, that means I'm taking away the energy, taking away energy from object. Like the box here, I pull it, I'm giving it kinetic energy. The friction is doing negative. So the friction is taking away the energy. The friction take the kinetic energy away and put it as heat. Then you get heat, loss of energy. Okay. Now that is the idea behind positive negative. Now, number two, the force and the distance must be in the same line, So if your object, you pull it, you attach a string like this, let's say 30 degrees. Okay, it's traveling in this direction, 5 meters. This is 10 Newton. What is the work done? You have to resolve the force into same line. You cannot take different line here. F and D must be in the same line. So you have to do 10 cos 30 times into the 5 equals to the work done. Again, after you resolve it, your force will be horizontal. This is the horizontal component, and it is the same direction as the distance. So again, this would be a positive work. Okay, now for the work done, we are always talking about constant force. The force applied is constant value. I pull it 10 Newton, I constantly pull it 10 Newton. So if I do the graph of force over time, my force is going to look like this. Horizontal line, like this. Okay? Same. You can say you can do F against T, or you can do F against S. Force against displacement. This will be also horizontal line. Constant force. So the area, Fs, the area of the graph, which is a square or rectangle, the area would be equals to work done. Let's say you have your variable force. 你的 force 不是固定的，是变来变去的。真正在 reality 的时候，你的 force 一定是不是一样的嘛 ？Okay, in reality, your force always changes. So in reality, the force will look like this, be like this, different shapes. Okay, increase, decrease over the distance. So how will you calculate the work done? This will not be asked in SPM. Yes, it will not come out in SPM, but your school test, that one maybe depends on your teacher. If the teacher got teach, then it will come out in your exam. It might come out, but in the SPM, they will not ask you this. Okay, they will not ask you this variable force. So if the variable force, you want to calculate the work done, how do you calculate? You calculate the area under the, again, area under the graph, AB. Okay, how do you get the area under the graph? You need to do integration. Okay, integration, AB, and then the equation F ds. Yeah. Right. What are the examples where work is done and work is not done? You see, like the first example, the reaction does not do any work on this one because it is perpendicular, right? So if movement is not in the same line as force, then there's no work done. For example, the Earth rotates around the sun. The Earth goes in an orbit. What is the force pulling the Earth? The force pulling the Earth is towards the sun. The sun asks the Earth to come here. But due to whatever reason, the Earth doesn't want to come here. The Earth want to go here. That is the distance traveled. This is the force. Not in the same line. Is there any work done? There's no work done. We say that there's no work done by the force F. Other forces might be doing work on it. Yes, but this F here is not doing any work on this Earth. Okay, let's say if I got another force here, F2. Is the F2 doing any work? Yes, F2 is doing work because F2 is asking the Earth to come here, and then the Earth comes here. So you have distance, you have force. So this is doing work. But F1, it asks the Earth to come here, but the Earth is not coming here, so it's not doing work. Okay, so in this case of the orbit, there is no work done. Okay, same as if you here, you push a wall. No matter how hard you push the wall, you apply all your strength until you feel exhausted. But are you doing any work? You are not doing any work. Why? Because no matter how hard you push the wall, you have force, but there's no distance. Nothing is moving. You can argue and say, okay, I use all my power to push it. I've done so much work. But according to physics, you have done nothing. There's no work done because there's no distance. Okay, so 3 criteria for work to be done. What are the 3 criteria? First, you need force. Number 2, you need displacement. Number 3, you need them to be in the same line, in the line of force. I will write here distance in the line of force. Okay, so one example, simple example. Here, I raised a box 2 kg. How much work I've done if I raise it for 10 meters? Okay, very simple. I just calculate W equals to 10 times 20 equals to 200. 200 Newton positive work. That is the work done by me. By me, okay? If the question asks you, what is the work done by gravity? By me. This is work done by gravity. Work done by gravity, then I will do again W equals to F times D. What is the gravitational force pulling? It's the same, 20. So equals to 20 times, distance is also the same, 10 is 200 also, but we have to put a negative here. Why we have a negative? Because the force is opposite to the distance moved. This is the gravitational force. That's why you have a negative. So question asks you like that, that is your answer, minus 200. Work done by me, 200 positive. Okay, and understand again the difference between work done by and on. Work done by means who is the one applying the force. By me, I'm the one applying the force. And then work done on is the force is applied on what thing? What is the object where the force is applied on it? Work done on the box, and work done by me. Okay, in the example of a moving car, the car moving and then the brakes are applied to stop it. Work is done by the braking force, and the work is done on the car. In the case where the car accelerates, work is done by the engine force, and work is done on the car. Okay, so there's a difference, by and on. Right, we go to the next slide. Now, how is work related to energy? Work and energy, they are very closely related. Now, I give you one example. Here, if I rub my hand like this, I create 20 joules of heat. Okay, I do this like that. And then after a few seconds, it becomes hot. It becomes warm. So if I have done 20 joule of work, that means what? that means my body now has minus 20 joule of chemical energy. So let's say my body started with 100 joule of chemical energy. Okay, I do like this. I have used 20. So my body minus 20, my body now got 80 chemical energy. Okay, and then this 20 stays here. It doesn't stay here very long. It goes into the surrounding. It goes into the atmosphere. So when it goes to the atmosphere, what happened to the atmosphere? Initially, the atmosphere got 200. Now 20 go to the atmosphere. Now the atmosphere got 220. My body minus 20, and the 20 is added to the atmosphere. So we say that the 20 is transferred, correct? 20 from my body, go to my hand, go to the atmosphere, is transferred. The transfer of the energy is where work is done. So we can say that work is equal to the transfer of energy. Okay? You see, chemical energy minus 20, atmosphere plus 20, and then the process of the 20 going from here to there, that is the work done. That is the work done. Okay? So understand that. If I say I've done 50 joule of work, what does it mean? It means that 50 joule of work must have been transferred from one to another one. Okay, from one state of energy to another one. I do 100 joule of work. 100 must be transferred from somewhere to somewhere. Something has to minus in order for something to be added. This minus, this plus. You cannot have plus and plus. No. That is the conservation of energy, because you cannot create energy. When I rub my hand like this, I'm not creating the 20. I'm taking the 20 from my body. Where does my body get the 20? Where does my body get the 100 joule in the first place? My body get it from the food I eat. Where does the food get the energy? From the photosynthesis, from the sun. So everything can be traced back to the sun. That's why we say the sun is the primary source of energy. Okay, now, when the heat goes from my hand, it goes to the atmosphere. What happens when it goes to the atmosphere? Does it stay there or does it convert to other form? The heat energy that stays in the atmosphere, it will stay there forever. It will not convert to other form. So that means the end product is always heat energy. It cannot be recovered. You cannot convert the heat energy back into useful energy like kinetic. You cannot convert that. Once it is become heat, then it will remain forever in the atmosphere. Okay, that is why we say heat energy is a waste of energy. It's a waste energy. Okay, waste in the sense that it cannot be converted back. People say we are facing energy deficit. You may have heard, right? If energy is conserved, if energy cannot be destroyed, how can we face energy deficit? The reason is because it has converted to heat. Okay, it has converted to heat, so it cannot be recovered. So we say we are facing energy crisis, energy deficit, right? So that's just to give you a picture behind it. Right, so energy is defined as ability to do work. You have energy, then you have the tendency to do work. When you wake up in the morning, if you feel very motivated, what do? You do more work, right? The things that you want to do, things that you have been procrastinating, you straight away you do it if you feel motivated. So when you have energy, when you feel motivated, you have the tendency to do work. You tend to do more work. You tend to do more activities. So that is the relationship. That's why we define it as ability to do work. That is energy, or you say capacity to do work. Okay, now Next one, we look at one very important principle in energy. The conservation of mechanical energy. Suppose that I throw a ball here. I throw it up. I give it initial velocity u. As the ball moves up, the speed changes, of course. So if the speed changes, then the kinetic energy changes. And then at the same time, the ball gains height. So it means that the height changes, the potential energy also changes. As the ball goes from here to the maximum point, it experiences a changing KE and PE. Okay, every second, it keeps on changing. One increase, another one decrease. By using the conservation of energy, we make a principle for this one. What is the principle called? We say this will be the this is conservation. Conservation of mechanical energy. Mechanical energy is a combination of KE plus PE. Okay, because the ball is undergoing the change in KEPE, so we study it, we would call that mechanical energy, conservation of mechanical energy. Now, what does the conservation of mechanical energy says? All right, let's say I first tossed it, I give it a certain velocity, so the kinetic energy is 100 joule at the bottom. Okay, what is the potential energy? Now, I want to make something very clear first. When I tossed it, I only look at when the ball leaves my hand. Between the point when the ball leaves my hand until the point where the ball is at the maximum point. Anything before and anything after, I will not look at it. Okay? It's like I trim it out of reality. I only take the duration between when the ball leaves my hand, not on my hand, leaving my hand. That means it's going to have a certain velocity. Okay, when it is on my hand, it is at rest. So I tossed it, it leaves my hand. Okay, I take this initial until when it is at the maximum point before turning back down. So I will write here, this is maximum height. And this is ball leaves hand. Okay, and I only study these two, the time frame between these two events. That is the first thing you want to make it clear. Okay, so when I say the ball leaves the hand, what is the kinetic energy? It's going to have kinetic energy, right? 100, let's say. What about the potential energy? Okay, it leaves my hand, but it's still very close. So potential energy, I would just say that it is 0 because it's too close to the ground or too close to my hand. 0 joule. Okay, at the maximum point, what is the kinetic energy? Going up, the velocity decrease or increase? Going up, the velocity decrease. Cannot increase, right? Because it increase, then it go way up, right? So the velocity has to decrease. The velocity go on decreasing. At a certain point, it's going to be 0. That is the turning point, the maximum point. Okay, so let's say I give it 100, 90, 80, 70, 60, 20, 10, 0 meter per second, V. When this happens, we say that it has reached the max height because it cannot go any further. The next second, then it will come back down. So kinetic energy at this height is going to be 0. What about the potential energy? Potential energy, if we calculate this one, is going to be 100 joule, which is the same as before the energy that you give it. At first, I give it 100. It cannot take 101. It cannot take 99. It has to be remain 100. That is the conservation law. Okay? But because we are only looking at KE and PE, so I will call it conservation of mechanical energy. Analyze these 2 points, this point here and this point here. What has happened? The 10 from the KE has go to the PE. You see, focus only on the KE. Before, it was 100. After, becomes 0, so minus 100. Now you focus on the PE. Before is 0, now is 100, plus 100. This one is like the example that I give you when I rub my hand. What happened? My body minus 20, the atmosphere plus 20. The conversion is the work done. So from here, the 100 go here, that is the work done. Work done is 100 joule. Okay, 100 joule of work. So here, from here. This is, we are taking the 2 extreme. I said the 2 points extremes. We are not discussing any point in the middle yet. So I can write from here, the 2 extremes, KE loss. What is the amount of KE loss? 100 minus 100, right? Is going to be equals to PE gain. Kinetic energy loss equals to potential energy gain. Can we write an equation for this one? Yes, we write kinetic energy loss. How do you calculate that? Kinetic energy at this point is half mv square, and kinetic energy at this point up here is half mv. Okay, let's put this as v1, v2 square. If I want to calculate the change in the kinetic energy, then I will take this one minus this one. Okay, what is the loss? The loss will be KE loss will be, I take the KE at the bottom minus the KE at the top. That is KE loss. Okay, what is KE at bottom? 1/2 mv1 square minus 1/2 mv2 square. Okay, then I factorize this half mv1 square, okay, minus v2 square. This one is the same as if I write it as m, the change in v square. The change in v, v1 minus v2. Whenever you see this symbol delta, it means the difference. Okay, the difference. Same here, PE gain. How much is the PE gain? PE gain. Okay, we do mgh, mgh1 minus mgh2. Which one minus which one? Sorry, this one should be, let me write it here. Up here is mgh2. Down here is mgh1. Okay, so gain, how much gain? I take the bigger minus smaller. So mgh2 minus mgh1. Then I get mgh2 minus h1. That's mg change in h. Okay, PE gain and KE loss. So I can equate this to half m change in v square equals to mg change in h. Then you get this formula. This formula, you will use it all the time. Same formula, but they give you different story, different questions. They tweak the question a bit, but in the end, it's still the same law. This one is what law? What is this law? Conservation of mechanical energy. This one says conservation. This equation used when you are taking the 2 extreme. Okay, the 2 extreme point. This is at the bottom. This is at the sorry, this one is applied from, let me write it like this, between bottom and top. Okay. So let's say I toss the ball. At first, I give it initial velocity of 100 meters per second. The ball has a mass of 2 kg. Okay, the mass sometimes given, sometimes not given. So I toss it with 100, go up. Question asks you, what is the maximum height it can achieve? Maximum height. Okay, then you can calculate what is the KE loss when it go from bottom to maximum height. Again, you're talking about the two extreme. So what is the KE loss? At first, I give it 100. I can calculate the KE loss, half m 100 square. That is going to be the KE loss, because at the top, KE is 0. Okay, then this one, mg, change h. The m I can just cross out, doesn't matter. If sometimes the mass is not given, you just cross out the m. Okay, so this one, 100 square and 0.5, 5,000. 5,000 equals to g change of h divided by 10, 500 meter. That is the change in h. Okay, so you are calculating the change. Change means if you know this is 0, this got to be 500. That is the difference between calculating the change and calculating a specific point. Okay, the change is 500. If you know the bottom is 50, what is the top? Then you would add the change, that this is 550 meter. If the bottom is 30, then the change plus the change, this is 530. If the bottom is 0, then the change is the same as the top, 500 meter. Okay, so there is a difference. Yes, there's a difference with the delta, and there's a difference with the delta, between the delta and also the energy at a specific point. Okay, what happened at the middle? At the middle here, then they take 50 joule here, 50 joule here, 50 joule PE, 50 joule KE. Now, again, one more thing. The conservation of mechanical energy, same as other conservation. What is the criteria? The criteria is no external force. External force, a lot of people confuse. Sometimes we are not sure what is external, which one is external. Is gravity an external? Okay, all that. External force is something coming from outside the system. When I throw the ball, what is my system? When I throw the ball, the system is the ball and the earth. Remember, what is that again? When I throw the ball, the system is the ball and the earth, because the earth is applying gravity on every single object on it. So the earth has to be involved. Okay, so consider the ball falling down. What is pulling it down? The gravity pulling it down. The force is pulling it down. Is the gravitational force an external force? No, because the earth, we count it as our system. Okay, again, our system got two bodies, the ball and the earth. The force coming from either one of the body, they are called internal. They are not external. Okay, If the force coming from outside, like the air resistance, then that is external. Or if I suddenly jump in and then I push the ball, okay, then that will be, again, external force, because originally the system only got the ball and the earth. I'm the third body. The air is a third body. Okay, so force from any body that is initially outside the system, it is an external force. But gravity is not external force. Okay, like momentum. In momentum, you learn about body go on and hit another body, right? Let's say body A go and hit body B. This, you have a system. What is the system of this one? Body A, body B, and the earth. Okay, so is gravity an external? The gravity acting between these two, is gravity external? No, it's not external, because we take the earth as our system as well. When body A go on and hit body B, it apply a force F. Is this force external force? No, because this force coming from body A, and body A is originally inside the system. Then what is external force? Okay, suddenly there's a person come in, push it. Okay, this person initially is outside. So this is an external force. So what happens if you have an external force? If you have an external force, then the energy no longer conserve. No longer what? No longer conserve. What does it mean? It means at first you have 100. Remember we did our 100 here. And then when it go up, it also got 100, right? 100. This is in the case where it is conserved. If got external force, no longer conserved means going up here, maybe it has only 90. It does not equal. So I would write here, KE loss does not equal to PE gain in the case where external force is applied. This is where external force. So that is one very important condition for conservation of energy. Whether it be mechanical energy or energy in general, they all apply the same thing. What we learn here is only the mechanical energy. That means we only discuss KE and PE. Okay, KE and PE. And during the calculation, when we use mechanical conservation, we cannot say that the ball hit the ground. If I drop the ball from a certain height, it falls down until before it hit the ground, so that the energy conversion remain only KE and PE. When it hit the ground, that you get heat. You get heat energy, you get sound energy. Then we are no longer discussing mechanical energy. We are discussing in general, more energy involved. Okay, but in this chapter, in this part, we only discuss mechanical. So if I drop the ball, then consider at the top and before it hit the ground. Anything after, I trim it out. 1 to 2 minutes. Then we go to the next slide. Okay, two examples. We tried it, and then we look at answers, very quick one. Then we continue to the next part. Anybody has answer? Number one, an object of mass 2 kg is thrown vertically upward, initial speed 10. Ignore air resistance. Okay, determine the speed when the object has traveled 3 meters vertically upwards. When it had reached 3 meters upward. Is this the maximum point? No, it's not the maximum point. It's halfway. So if it's halfway, you need to be careful that you have KE and PE both together. At this height, you have KE plus PE. Only at the maximum point, the KE is 0. Okay, so there are values of KE and PE. Now, calculate the KE. Initial, how much KE do I give it? I toss it with 10 meters per second, so I can calculate KE equals to, at this point, is going to be half mv squared. So half times 2 times 10 squared. This is 100 joule. Okay, 100 joule. So at this position, the PE is 0, correct? At the bottom. Yeah, PE is 0. So that means KE is the total. 100 is the total. 100 is the total energy of the ball. Okay, so that means you know that over here also must be 100 because conservation of energy. Here total is 100, here total must be 100. So then how do you know the KE at here? They want you to calculate the speed at here, right? V. You can first find what is the KE at this height by calculating the PE. Okay, so PE equals to mgh. So it's going to be 2 times 10 times 3, 60 joule. So if this is 60 joule, the total must be 100, then KE is 40. At that height, the kinetic energy of the ball is 40. So at 3 meters, KE is 40 joule. So to find speed at that height, I'm going to be half mv squared equals to 40. Okay, so equals to half times 2 times v squared equals to 40. Cancel. This is v square root 40. This is going to be 6.32. Okay, example 2, a ball of mass 50 gram, thrown vertically upward. Find the maximum height that it can rises. Okay, maximum height. So that is the two extreme points. Okay, then we can say the KE at bottom is equal to the PE at top. Cross, we get half 30 square equals to 9.81 into H. Okay, B, find the speed when it is 10 meter above ground level. B 就很像你的第一题 find the speed when it is 10 meter above. 10 meter, not the maximum point. The maximum point is 45. So this is only a quarter of it. That means it's going to have PE plus KE. Okay, what is the PE down here? PE is 0. And the KE is half times 0.05 times 30 squared. Okay, so PE 这边我们算 mgh 等于0.05 9.81乘10 4.905。OK， 这样子我们就可以算这里的 KE。OK， so KE 等于22.5减掉4.905 17.595，然后我们就用这个来找 V。 OK 啊，来，我们继续啊，下一个，我们多一个小 part 就。我先把这个擦掉先。I want to keep the exercise number 2 when I explain this one. Okay, like this part, I want to talk about the work energy principle. Okay, you see what we discussed just now, conservation, right? Conservation of mechanical. Here we have come to another principle, the work energy principle. What does it mean by work energy principle? Okay, very simple. Let's say you have a car. The engine force acting on the car is 50. And then the car travels due to the force acting. The car travels a certain distance, S, and initial velocity, U, and final velocity, V. Okay, so let's say we have a force acting on the body. What body? The car is one single body. We have the force acting on it. Okay, now we can calculate the work done due to this force, right? Is it a positive work or negative work? It's a positive, right? Because Fe engine 的 force 是跟这个 distance 一样 direction， 所以它是 positive work。所以如果我算 work done Fe 乘 S equals to, this is a positive work. I will write here positive work. And the F, I can also convert it to MA times S. Okay, MAS. Now we have learned acceleration, V square equals to U square plus 2AS. If I express this one, I can write it as, okay, V square minus U square equals to 2AS, and V square minus U square over 2S equals to A. This one, I put it here, equals to M V square minus U square over 2S. S 这个两个 cancel. 我拿到什么 equals to the M I times in MV minus MU square over 2. Okay, so this one I can write it as 1 over 2 MV square minus MU square. So 1 over 2 MV square minus 1 over 2 MU square. 这个什么来的 ？Kinetic energy final. 这个是我的 KE final. 这个是我的 KE initial. Final 加 initial 那个就是 change 咯。所以 work done 也可以把它写成 change in kinetic energy. So I will write it here. W equals to the change in kinetic energy. This, you want to remember this, is the work energy principle. Now, 他在讲什么？你看，如果我的 work 是 positive， 你放进这个 equation， 如果我的 work 是 positive， 我搬那个 positive 过去，它也是 positive， 对吗？ Positive change 是什么意思？ Positive change 是什么意思？ Positive change 就是你的 kinetic energy increase 了。这个是 positive change。因为 change 我们是永远用final value 减掉 initial 的吗？对吗？如果我的 change 是加，意思说我的 final 是比较大咯。OK，final 大过 initial， 我的 change 就是a positive value。So 当 work done 是 positive work done 的时候，你的 change in kinetic energy 是在增加的，是在加。所以如果你做如果你你 do work on the object and the work you do is a positive, then you are increasing the kinetic energy of the object. So just like this example, the engine force is doing certain work on it. Okay, so let's say the distance is 10 meters. What is the work done? W equals to 50 times 10. Okay, you are doing, the engine is doing 500 joule of work. That means it's a positive or negative? It's a positive work, right? So that means the car will gain 500 joules of kinetic energy. Okay, the car will gain 500 joules. Now, I only say the car gain. I did not say what is the initial energy of the car. If the car initially has 100 to start with, then after this work done, it has how much? Now got 600. If the car initially got 200, because it initially is also moving, right? If it got 200, then after the work done, now it has 700 joule. So understand this is, the 500 is, what is that? That is the change in the KE. That is the amount of increase. Okay, so if your work is negative, W equals to change in KE. 如果你的 work 是 negative， 你把那个 negative 放进这边，然后你的 negative 搬去对面，你拿到什么 ？W 等于减，然后 change KE。这个代表什么意思？这个代表你的 KE decreases。你讲拿到减，你就是因为拿 final 减掉 initial， 然后你拿到一个 negative value， 意思说你的 final value 小过你的 initial value， 所以它就是 decrease 来的。Okay, example, 如果有 friction acting on the car, the force of the friction is, okay, 5 Newton. What is the work done? 5 Newton times the 10. Okay, work done by friction. 5，我放一个减 ，OK， 5乘10等于减50。It's a negative work, right? Minus 50. So the minus 50 joule of work done, you know that is the amount of the kinetic energy decrease. Amount of kinetic energy decrease. Okay. So 你增加500，然后那个 friction 拿走50。Overall， 你的 kinetic energy change 就是增加450。This is the work energy principle. 他跟你讲什么 ？Work done directly affects the kinetic energy. And usually it only affects the speed because you cannot change the mass. The mass stays the same. You only can, when you apply the work, it only can change the velocity. Okay, so same thing here. Now, 如果你看回刚刚的那一个问题，这个从这边下面哦， 我的 kinetic energy 是多少 ？total 22.5，这边 ，OK， 在下面的时候 PE 是0吗？然后 KE 是22.5，所以 total 是22.5。Let's say 我要算在上面 B 这边的 KE， 用那个 work energy principle 来算。How do I calculate? I can calculate the work done first, right? 当我丢那个球上去，什么 force acting？ 当那个球离开我的手，我的 force 就不再 acting 那个球，只有 gravity 在 acting 那个球，所以那个 force 是 downward。How much is the downward force? Okay, mg F 等于 mg, so 0.05 times 9.81， 0.4905 ，OK, so 0.4905 Newton. Now, work done by gravity 等于减0.4905乘10，因为球往上走 ，gravity 的 force 是往下，反方向，所以我这边 work done by gravity 是 negative 减4.905 Joule， 代表什么？你拿到有减对吗？那你的 work energy principle work done 等于 change in kinetic energy， 减意思说你的 kinetic energy decrease by how much？ 4.905， 就是你的 work done。所以你的 kinetic energy 在下面是多少？ 22.5， 把它减掉 4.905， 你就拿到上面这边多少？就是我们说到的17.575。